So now we continue with this paper. We are dealing with question 4.3. See, there was a spelling error in the paper too. It's proved that the straight line 3y minus x minus 10, just double check on your question paper, everything is correct here. 3y minus x minus 10 is equal to 0 is a tangent to the circle x squared plus y squared is equal to 10. Find also the point of contact. Okay, so now we have a circle. Okay, so this is a straight line. So here's your circle. So if the straight line touches the circle, at one point only, then it is a tangent to the circle. Okay, so it could touch on this side, it could touch on this side here. Okay, just using an example to show you. So what does it mean now? These two graphs are intersecting, and they are intersecting at only one point. So therefore, if the graphs intersect at one point, okay, that means the straight line is a tangent to the circle. Okay, if it's going to cut through, then it is not a tangent, it will be a secant. Okay, so prove that the straight line is a tangent to the circle. So what we're going to do is we are going to solve simultaneous equations. Okay, and let's see how many points or how many solutions do we have. Okay, if we come out with only one solution, that means there's only one point of contact. Okay, if we come up with two solutions, then there's 2 points, that means the straight line is cutting the circle twice and it's not a tangent. Right, so let's try it out. Let's see what happens. Right, so what do we have? Equation 1, we got 3y minus x minus 10 is equal to 0. And the second one here, we have x squared plus y squared is equal to 10. Okay, so what can I do now? I can take the straight line, substitute into the circle. Now what do? I either can make x the subject of the formula or y the subject of the formula. But let's make, which one is better to make? It's x, because we will have no fractions. We want to try and avoid having fractions. Okay, so if I make x the subject, so I will take x to the right hand side. Okay, so I take x to the right hand side. If I take x to the right, it will be positive. Okay. Then I have, it's a 10 here, also a 10. Okay. So then I have 3y minus 10 again, which is minus 20. You're clear with that? Okay. So 0. Okay, let's hold on there. How is it 0?
So it's y minus x minus 10 is equal to 0.
Oh, sorry. My mistake. Where am I getting it? It's a 0. Yes. So that's just 3y minus 10. Minus 10. Yeah, I wrote down. Yeah. So now x is equal to 3y minus 10. So now we will substitute. Right, so now I'll take 3y minus 10, replace x in this equation. So that will be 3y minus 10. Now we have only one unknown, which is y. What we're going to do is we will square it So 3y, we can square this in one step. Okay, so 3y squared, that will be 9y squared. Then the middle term is going to be 2 times the first term times the second term. So 2 times, okay, minus 3y times 10 is minus 30y, times 2 is minus 60y, and then minus 10 squared is plus 100 plus y squared is equal to 0. Okay. So 9y squared plus y squared I will get 10y squared, and then I have minus 60y. Okay. This 10 on the right hand side, if I bring it to the left, it's going to be minus 10. So 100 minus 10 will be 90, equal to 0. Alright. So now we have a trinomial. So okay, we need to factorize and solve for y. But can I make this simpler? Yes. I can divide by 10 here. Okay, I can divide by 10. So if I divide by 10, divide by 10, divide by 10 there, divide by 10, let's see what happens. So 10 over 10, that will just give me 1y squared. And I got 60 divided by 10, which is 6, so that's minus 6y. And then I got 90 divided by 10 there, which is 9, equals to 0. Okay, now we can factorize this trinomial. Y squared minus 6y plus 9. So if I factorize this, what are the factors here? We know if it's a minus plus, it will always be minus minus. Okay, why? Because if you add two negatives, you get a negative. If you multiply a negative times a negative, you get a positive. So y squared can only be y times y. Are we using 9 times 1? No, 9 times 1 will not work, so it will be 3 times 3 there. Okay, so now this is the same as y minus 3 all squared. Y minus 3, anything multiplied by itself, you can see there. It's like exponent laws. K times k is k squared, y times y is y squared. Y minus 3 times y minus 3 is y minus 3 squared. So that means y, if I find the square root of both sides, so y minus 3 is equal to 0. So y is equal to 3. So what do we notice now? There's only one y value here. Can you see that? There's only one point of contact here, one y value. So when y is equal to 3, what is x equal to? Let's substitute it and see. What is x? X is equal to 3y minus 10. So at y equal to 3, x is equal to 3 times 3 minus 10. So that's 3 times 3 minus 10. So 3 times 3 we get 9 minus 10, which is equal to minus 1. Okay. So therefore the point of intersection is minus 1 and 3. There is only one point of intersection here. Okay, that means the straight line will touch the circle at only one point. But how can we make sure that this is correct? Okay, how can we do this? Let's have a look at a picture of what's going on here. here is minus 1 and 3 there. Okay. What is the radius of the circle? Let's get the circle. What is the radius? It's x squared plus y squared is equal to 10. Okay, so we're going x squared plus y squared is equal to 10. So we are dealing with a circle with the center at the origin. So the equation of the circle x squared plus y squared is equal to r squared. So if I compare the right hand side of the standard form and the equation that we are given, so now I can see that r squared is equal to 10. Can you see that? So r is equal to the square root of 10. What is the square root of 10 there? That's it? 3,16. So 3,1, let's just say 3,2. Okay. Right, so your r is equal to 3,2. So then that's minus 1, minus 2, minus 3, so that's 1, 2, 3 there. So 3,2 is somewhere around there. So we got 1, 2, 3, maybe 3,2 is there. Okay. So if I'm going down, minus 1, minus 2, minus 3,2. Right. So here's a circle. Now what's happening here is the point of intersection is minus 1, 3. So minus 1 and 3 is somewhere here. Okay. So the straight line is touching only at this point here. So if I draw my straight line there and there. Okay. So this is my straight line. Right, so what do we know about tangents and circles? Okay, we want to make sure that this is correct. Okay, we want to make sure it's correct. So, what do we know about a tangent to a circle? At the point of contact. Okay, what do we know about a tangent and a circle? The tangent is perpendicular to the radius of the circle. Okay, so if I draw a line from there to the center, this should be 90 degrees there. Okay, if it is 90 degrees, that means it's perpendicular. That means the gradient of the tangent times the gradient of the radius must equal to what? Minus 1, perpendicular. If it's perpendicular, it intersects at 90 degrees. Okay, so this point here is 0, 0. So what is, this is the radius. Okay, that is the radius. So if I want to work out the gradient, I got my 2 points. If I want to work out the gradient of the radius, so if I'm going in radius, it's going to be y2 minus y1, 2 minus 0, x2 minus x1, minus 3 minus 0, so which is equal to minus 2 over 3. That's the gradient of the radius. What is the gradient of the tangent? Okay, so what is the gradient of the tangent? Let's write down the equation of the tangent. So here is the tangent. Okay. So how do I work? How do I get the gradient from here? What do I do? All I have to do is write it in standard form. Y is equal to mx plus c. M is the coefficient of x, m is the gradient. Okay, so 3y is equal to x plus 10. So now, what do? Just divide by 3. So y is equal to x over 3 plus 10 over 3, which is the same as 1 over 3x plus 10 over 3. So now, let's see what's going on here. So, m tangent is equal to 1 over 3. M radius is equal to minus 2 over 3. Okay. Now that was minus 2 over 3. So now, m tangent times m radius so my m tangent there is 1 over 3 m radius minus 2 over 3. Okay. Doesn't look like it's equal to minus 1, yeah? Can you see that? 1 over 3 times minus 2 over 3 minus 2 over 9. Okay. So, did we make a mistake somewhere?
The point.
Yes. Oh, sorry. Yes, sorry, that's minus 1. Sorry, that's minus 1 and 3. Minus 1 and 3. Okay. That's 3 minus 1. That was my mistake here. Okay. I should have recognized that that time I copied down the wrong value. So that's minus 1 and 3. Minus 1 and 3. So that's 3 minus 0, which is 3 minus 1 minus 0, which is minus 1. So therefore, so now it works out perfect. Okay, you see my mistake was I transferred the information incorrectly from here to there. See, that was the problem. Alright, so 1 over 3 times minus 3 is minus 1. Okay, so we know now that this is definitely, this point is correct. Okay, we know now this straight line is a tangent because we multiply the two gradients, it's equal to minus 1. So what was the question? Prove that the straight line is a tangent and also find the point of contact. Okay, so here is the point of contact. Point of intersection also point of contact. Okay. Now that's basically it for this question. Here's the next question now. Determine the equation of the line through the point P, which is 2, -3, and parallel to the y-axis. Okay, so determine the equation of the line. So this is a straight line. What do we need? We need the gradient and we need a point. Okay, but what is important to note here is parallel to the y-axis. Okay, so what does that mean? The best thing is just like what I did there. Let's draw. Let's see the picture. So here's a point P, 2, -3. So when x is 2, so that's 1, 2 there. 1 minus 1 minus 2 minus 3. So here is this point here. Can you see that? This is the point when x is equal to 2, y is equal to minus 3. And here is, this is the y-axis. Can you see that? So it's a line parallel to the y-axis. So this line, there's the y-axis here, the line must go like this here. Can you see that? So you take your ruler and you draw a straight line. Okay, so there's the y-axis. It is parallel. So what is the equation of this line? It's just x is equal to 2. That's why it's 1 mark. Right, that's why it's 1 mark. You can see that. Because it's just a line parallel to the y-axis passing through the point 2. I can also give you a question. Find the equation of a line parallel to the x-axis passing through the point, the same point. Okay, then I will draw a line here now. It will be y is equal to minus 3. Okay, so the best thing is to draw and see what's going on. Simple straight line picture. Okay, let's move on to the next one. Pause there. Right, so I didn't write down the whole question there. It says consider figure B. We got point A in the second quadrant, point C in the fourth quadrant, point B in the third quadrant, and you have this angle here. So these are all straight lines. AB is a straight line, AC is a straight line. This is the origin. That's a y-axis, x-axis. This is a 6-mark question. Okay, so what does the question state? Determine the equation of AB. So here is AB. Right. So if again, we are finding the equation of a straight line. Right, so what do we need? We need the gradient and we need 1 point, always. Right, all you need is the gradient and 1 point. Do we have a point that lies on the straight line? Yes, we do. We got point A. Right. So let's just write that down. We need M, which is the gradient, and a point. Right, so we have point A, which is minus 1, 2. The problem is we do not have the gradient. So how can we find the gradients? We can use the formula we've used there, y2 minus change in y over change in x. We need 2 points. We can't use that now. That's a problem now. Can you see that? We only have 1 point. We don't have the value for x and the value for y. Alright, so how do we get the gradients? Okay. Now, we can't use calculus. This is not a section in calculus. Okay, in calculus it's a first derivative, but we don't have an equation here anyway. So in analytical geometry, okay, let's go back to this point here. This is an angle that's measured from the positive x-axis to the straight line. What is this angle called? Okay, it's called theta, but in analytical geometry, it's called the angle of inclination. See? Angle of inclination. Now, what is an angle of inclination? It's just an angle that's measured from the x-axis to the line. Okay. That's also an angle of inclination there. Okay. Now, if I can find this angle here, then I can use the formula tan theta is equal to the gradient. You remember that? But the thing is, I need this angle first. So how do I get this angle? Okay. So if I know this angle, I can work out this angle, and then this is a triangle here, and then I can work out this one. Or this is an exterior angle of the triangle also. Okay, so but let's work it out first. I need to work out this angle here. How do I do that? Okay, let's write it down. So tan of theta is equal to m. If I want this angle, I need the gradient of line AC. Can you see that? So therefore, I need to first find the gradient of line AC. So let's do that. So m of AC. So I'm going to go y2 minus y1. You are following what I'm doing here? I'm going to go y2 minus y1, and I'm going to go x2 minus x1. Or you can go up there. It depends on which way. It doesn't matter. You're going to come to the same answer. You can start, if you're calling this one y2, this must be x2. And this one will be x1, y1. Okay, so if you're calling this one x2, this must be y2. And this will be x1, y1. Right, but you must go in order. You can't go and just swap it around. So I'm going to go y2 minus y1. So I'm going to go 2 minus 1, which is going to be 2. Let me just write that down. 2 minus 1. So that's y2 minus y1. And then x2 minus x1. So this is going to be minus 1. Alright, so now this is going to be 2 minus and minus will give me plus. So 2 plus 1 is 3. Minus 1 is minus 2. So the gradient of AC is minus 3 over 2. So now tan of theta is equal to minus 3 over 2. All I'm doing is substituting here, you can see that. So I need to work out theta. Now, there's two ways to deal with it. Okay, it depends on how you did it in class, I'm not sure. One is to use the negative in the calculator. The other method is to ignore the negative and you use 180 minus. Okay, I'm not sure how that you'll do it in class. Let me just ignore the negative. You'll see what I'm doing. So if m is less than 0, then theta must be 180 degrees minus inverse tan of positive m. Okay, this is ignoring the negative sign. Okay, so what I'm going to do is, your gradient is negative here. It's clear that it's negative. You can see the straight line is going down. If you got a positive answer, you know you made a mistake because look at the straight line. It's decreasing. It must have a negative gradient. So theta is equal to 180 minus inverse tan, and we ignore the negative sign because I used 180 minus. Right, so that will be 3 over 2. Let's work it out. The calculator. Make sure your calculator is in degrees. So that's 180 minus inverse tan, 3 over 2, which is equal to 123,690. Okay. This is 123,690. So now, and you can see that this angle is greater than 90 degrees. If you got an answer less than 90 degrees, you know it's wrong. Look at the shape. Here is 90 degrees, straight line. This one is less than 90 degrees. So this is more than 90 degrees. Okay, yes. Sorry? Yes. Okay, I'll explain that to you now. Alright, so what's going on here now? We're talking about 56, you're talking about this one here, 56,3. Inverse tan 3 over 2. Okay. Alright, so now, if you do this on a calculator with the negative as it is, okay, this is what you get. So if I go inverse tan minus 3 over 2, okay, let me just do that. So let's say I'm doing it this way. If I go theta is equal to inverse tan of minus 3 over 2. Now, if you use the negative on the calculator, then it's giving you minus 56, 3099324 Basically, it's going to be minus 56,31. Alright, so this is as it is without using 180 minus. So what does negative mean? So negative means that you are measuring clockwise now. That means you are measuring going down. Okay. Positive angles are measured anti-clockwise. So minus 56,31, there's it here. It's going down. The negative indicates the direction of clockwise, so this here is 56,31. So how can we check if this is correct? Okay, one second. Let me just explain that to you. This is a straight line. If I measure the angle of a straight line, what is the angle of a straight line? 180 degrees. So add this up on a calculator. What do you get? Add it up on a calculator. 123,69 and 56,31. You get 180 degrees, so you know it's 100% correct. Alright. But you do not put the negative. The negative only indicates that you are going down. Alright, so now, let me just finish and then we'll deal with one. Right. So now, I'm not sure if you're doing it this way in class or this way, but these are both methods now. So what happens if you did it like this here? Then you will have to write down 56,31 and then subtract 180 minus 56,31, which will give you the other angle. Alright. Now, angle of inclination is measured anti-clockwise. Okay. So now, what do we need? What was the aim here? We need the gradient. We need the gradient, so we need this angle here. Let's call this angle alpha. Okay, let's just call it alpha. You can call it any angle. It's up to you what you want to call it. Okay. How do I work out this angle? Now, you can do it the long way, or you can do it the short way. Okay. The long way will be, you want to get this angle here, and then you work the sum of the angles of the triangle give you 180 degrees. Or, there is another theorem. Okay, the theorem states that the exterior angle of a triangle is equal to the sum of the two interior opposites. So, let me just explain to you. This is exterior on the outside. So, this is interior on the inside. And what's opposite interior? There's opposite there, there's opposite there. Can you see that? So, that angle plus that angle is equal to 123. Okay, I'm going to use a short way. Alright, so I'm going to go. So I'm going to go alpha plus 78,69. Okay, these are the two interior opposite angles. Is equal to the sum of the two. The sum of the two interior opposite angles is equal to the exterior angle of the triangle, which is 123,69 degrees. Work that out there for me quickly. So we're going to get 123,69 minus 78,69 also. Which is equal to 45 degrees. Right, so we got that this is 45 degrees. So now, It's 45 degrees. So we know M is equal to tan of the angle of inclination. Okay. So that's going to be tan of 45 degrees, which is a special angle anyway. We don't need a calculator for this one yet. You should know your special angles, 30, 45, 60 degrees. Tan of 45 is 1. Tan of 45 degrees is 1. So now, we work out the equation of the straight line. That was the question. Okay, so I'm going to use this one here. I'm going to use the point gradient form. The point gradient form of the straight line is y minus y1 is equal to m into x minus x1. It's just that I prefer to use this one. You can use y is equal to mx plus c. You're going to come to the same answer. It's just that I prefer to use this formula here. So I'm going to go y minus. This is my y1 and this is my x1. So I'm going to go y minus y1 is equal to m into x minus x1 there is minus 1. So y minus 2 is equal to x plus 1, because minus times minus will give me a plus there. And then y is equal to x plus 1 plus 2. So y is equal to x plus 3. And that was your 6 marks there. Okay. Alright, so you wanted to ask me something, or you're clear about everything?
I'm clear, I was just saying that
Yeah. Oh, yes, yes. Okay, you're looking at that's good. Okay, what is he saying? Alright, so I didn't think of that. I wasn't thinking about parallel lines and vertically opposite. Okay, which is good. Okay, what is he saying? That when two straight lines intersect, okay, that's what he's saying now. When two straight lines intersect like this here. Okay, then you have, if I call this angle theta, this angle will be also theta, because it's called vertically opposite angles. Okay, it comes from your theory in geometry. Vertically opposite angles are equal. Okay. So, if this is 56,31, that means this is also 56,31. Does it make sense? Check. This is also a straight line. The x-axis is a straight line. So if you add up 123,69, this has to be 56,31. It must equal to 180 degrees. Okay, then you could obviously work out the other angle. So that's good. You're thinking differently. All right. Right. Right, so let's continue with this problem here. Now we are question 5. Sketch the graph of 25x squared plus 4y squared is equal to 100. Okay, so we got a plus here. It could be a circle. Or there's another graph that you sketch. It's called the ellipse. Okay, so how do we know whether it's a circle or an ellipse? You can always work out the x and y intercepts. If I let y equal to 0 here, then 25x squared is equal to 100. So x squared is equal to 100 divided by 25, which is 4. So then x is equal to plus or minus 2. Okay, then if I let x squared equal to 0, definitely the x and y are not equal here. Can you see that? Right, so that's one way of doing it. The other way is, if you know the standard form, this is the standard form of the ellipse. Standard form is x squared over a squared plus y squared over b squared is equal to 1, where your x-intercepts are equal to plus or minus a, and your y-intercepts are equal to plus or minus b. If you know that standard form, then you can always try and rewrite it in standard form. Let me just show it to you. Okay. So the standard form, if you look at the right hand side, the right hand side is a 1 there. Can you see that? So if I divide by 100, 100 divided by 100 is equal to 1. So that's divide by 100, divide by 100. Okay, what I'm trying to do is rewrite it in standard form. Okay. So 100 over 100 is 1. Okay, 4 over 100. That's 4 times 25, so that will be y squared over 25. 25 over 100, that's 25 times 4, so that will be x squared over 4. You can see that? So, your standard form is x squared over 2 squared plus y squared over 5 squared is equal to 1. So basically your a value there is 2, which is the x-intercept, it's going to be plus 2 minus 2. And your y value there is, your b value is 5. So you just go and sketch the graph. So we're going 1, 2 there, minus 1, minus 2, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So that's your ellipse, those are the values. There, there. That's your ellipse. And it just asks you to sketch the ellipse. No problems there. Right, you can always work it out. If you want to work out how did I get the plus 2 and minus 2, you can go to, for x-intercepts of any graph, let y equal to 0, you will get x is equal to plus or minus 2. If you want to work out y-intercepts, you get x equal to 0, and you get your y values. Okay. Right, so now we move on. Moving on quickly. Question 5 is calculus, differentiation. Okay. It's around 8 to 10 marks in N3. Okay. Then calculus, you are in N4, it will be around 40 marks in N4. Okay. Then N5 and N6, when you come to my class, that will be next year. Okay, N5 and N6. Then everything is calculus. The whole syllabus is calculus. Right, so you're building up towards calculus. Right, so what we're doing here is similar to what you did in grade 12, maybe it's just a little bit easier. Right, so how do we do this? Here, determine dy over dx. They did not say by first principles. So we are just using the rules of differentiation. So what are the rules of differentiation? If y is equal to k x to the power n, okay, then the first derivative dy over dx, how do we apply this rule, the first derivative? You will multiply your coefficients by the power, so that's going to be k times n, copy down your base, which is x, take the original exponents, and subtract 1. That is your rule for differentiation. So, I need to make sure that every single term looks like this here. In standard form, it must be multiplication. Okay, it must be a number times your variable x, and you have a power, which is n there. So now, I want to rewrite this. So this is divide by 4. It's the same as multiplying by 1 over 4. You're clear with that? So this is the square root of x, which is x to the power half. Now follow what happened there? So yeah, this is minus 1 over 4, but now x squared is below, it's in the denominator, it's below the division sign. So the standard form does not have x in the bottom, x is always on the top. So therefore, what you need to do is rearrange this using your exponent laws. So your exponent laws, if you take the variable from the bottom, or if you take any number from the bottom and to the top, what happens to the sign of the exponent? It changes. So therefore, if I take x squared to the top, it will become x to the power minus 2. So now it's all ready to differentiate. Okay. So now, once you start differentiating, you need to write down dy over dx. Okay, that is your first derivative. So I'm going to show all working over here. So my dy over dx, that's going to be 1 over 4. So there's my k multiplied by n. So that's going to be half times x. And we got n minus 1, which is going to be half minus 1. Here. Yeah. That's what's more important. Students or anything else? Students. Very good. But anyway, what do you think? Okay, so, alright, so what we were dealing with here is k times n, so that's k times n, x, n minus 1. So that will be half minus 1. So we're done with term number 1. Then number 2, that's going to be minus 1 over 4. That's k times n, which is minus 2. That will be x minus 2 minus 1. Nothing confusing here. All I'm doing is multiplying and subtracting 1. That's the only rule you use here in N3. Then next semester in N4, you're going to learn how to differentiate everything else. How do you differentiate sine, cos, tan, cosec, sec, everything. Okay. For now, it's just multiplying and subtracting 1. So 1 over 4 times 1 over 2 is 1 over 8. X half minus 1 is minus half. Minus 1 over 4 times minus 2 will give me plus 1 over 2. X minus 2 minus 1 is minus 3. Now, in N3, you differentiate it, that's fine. But you will not get full marks. Full marks will be awarded only if your final answers are written with positive exponents. And that in third form, like that means if it can be written like this here, you will have to write it down. Third form. Okay. So this is a negative exponent. I need to make it positive. So that's going to be 1. Now, okay, this is where most people make a mistake. Alright, so let me just do this step by step. So that's 1 over x. Then x to the power minus half is the same as 1 over x to the power half. You okay with that? Yeah. This is plus 1 over 2. X to the power minus 3 is the same as 1 over x cubed. You can do it in one step, but I'm just explaining to you that you can change this to 1 over x to the power half. So now my exponents are positive, but now they are still not written back in third form. This is the only one that I have to write in third form. How do you know if something can be written in third form? The exponent is a fraction. You see that? If the exponent is a fraction, that means third form. So 1 times 1 is 1 there. 8 times root x, that will be 8 root x plus 1 over 2x cubed. They just gave you one question. Okay. Alright, the next one. Let's move on. So we are given the cubic graph. you're given this is the equation. Just double check on your question paper that I did not copy down the question wrong there. That's x cubed plus bn squared plus cx. Okay, we are told the turning points are A and B. So this is a turning point, maximum because it's the higher turning point. This is the minimum turning point. Okay, B, 3 and 0. That's the equation. So we are told prove that the values of B is equal to -6 and C is equal to 9. How do we do that? It's similar to a grade 12 question. Right, so now we need to find the values of B and C. Okay, so right, so that is the equation that we're given. Okay, so now what does this mean here? B30. It is a turning point. But is it only a turning point? No. It turns, yes, but it is turning on the x-axis. How do we know that it's on the x-axis? Because what is the y value? 0. So therefore, it is a turning point and also an x-intercept. So B30 is an x-intercept. So let's use this fact that if I substitute x is equal to 3 into the original equation, what must y equal to? 0. So therefore, f of x means y. Okay, so I will replace 0, f of x with 0, and wherever I see x, I will replace it with 3. So that's going to be 3 cubed plus b times 3 squared plus c times 3. So that 0 is equal to 3 cubed, which is 27, 3 squared, that will be 9b, and that will be 3c. Okay, so now I got two unknowns here, which is b and c. So I cannot work out this equation, okay, because it's only one equation. I need two equations. So how do I get the second one? I cannot work out the b and c, okay, because it's only one equation. I need the second equation. So we use the same. We only have 1 point to use. There's nothing else to use here. Can you see that? So B30 is also a turning point. Okay, so B30 is also a turning point. Now what do we know about our theory on cubic graphs, turning points? Okay, so what do we know? We know that at the turning points, or stationary points, whatever you call it, it can be called maximum, minimum point, turning point, stationary, all means the same thing. So at the turning points, the first derivative, f prime x, must equal to what? 0. Okay, what does that mean? It means, what does that mean now in the picture? That means if you draw a tangent here, the gradient is going to equal to 0. The gradient of the tangent is going to equal to 0 because the y values are the same. If y is equal to 3, 0. So the gradient is 0. There's a tangent here. Can you see that? The x-axis is now acting as a tangent to this curve here. So f prime x means the gradient of the tangent to the curve is equal to 0. So now, what is f prime x? F of x is equal to x cubed plus bx squared plus cx. Right, so f prime x, the derivative now. Again, we have to use our rule here. You can see that. So the derivative of x to the power 3 is what? It's going to be 1 times 3, which is 3. Copy down x, 3 minus 1, that will be 2. The derivative, remember, b represents a number. So imagine b as like 2, 3, or whatever. So it's going to be b times 2, which is 2b, x, 2 minus 1, which is 1. Right. Now, the derivative of cx. What is the derivative of cx? As you all know the shortcut in C. That is a shortcut. The derivative of cx is c. Now, we have to know our theory here because we need to use this information now. What is f prime x equal to? That means I can replace f prime x with 0. And more specifically, f prime of what x value? Of 3 is equal to 0. Okay. F prime of 3 is equal to 0. Okay, because that 3 is a turning point. That means if I substitute 3 into the first derivative, I will get 0. So, there's 3. That's going to be 3, 3. So now, we can work this out. So that's going to be 3 squared, which is 9, times 3, which is 27. 2 times 3, that will be 6b plus c. Okay, so now we have our two equations. So here is one equation, and there is the other equation. Okay, so we're going to solve simultaneous equations. Okay. So, okay, let me just take this constant to the left-hand side. Minus 27 is equal to 9b plus 3c. And the other equation there I have minus 27 is equal to 6b plus c. Now, how do you want to work this out? There's two methods that you learn. One is called elimination, and the other one is called substitution. Okay, substitution is you must make C the subject of the formula. It's just like how we did the first one, remember that? But elimination is going to be faster, I'm going to show you. Alright, how does elimination work? I need to make the coefficients of a certain variable equal. That means if this is a 3 and this is a 3, if I've got 3c and 3c, then 3c minus 3c will be 0c, so c will be eliminated. That's what I want to do. I'll use elimination first, and then once I get b, then I will just substitute and work out the other one. So let me just show you how elimination works. So what I'm going to do is, what I'm going to do on the top is divide by 3. Okay, so if I divide by 3 on the top, minus 27 divided by 3 is minus 9. 9 divided by 3 is 3. 3c divided by 3 is just 1c then. So what just happened now? I made the coefficients equal. So now I can eliminate C by subtracting top minus bottom. So if I go C minus C, that's out, 0C. Then I'm going to go 3 minus 6. What is 3 minus 6? Minus 3B. Then I'm going to go minus 9 minus 27. See what I'm doing now is I'm doing top minus bottom. So I have to subtract top minus bottom, top minus bottom, top minus bottom there. So minus 9 minus 27 is equal to minus 9 plus 27, which is 18. So you saw C is eliminated, I only have B left. So therefore 18 divided by minus 3 is equal to B. So B is equal to minus 6. That is true. Okay, now I don't have to go and use elimination again now. If I already have B, all I have to do is substitute into any one of the original equations and work out C. So let me choose this one. So minus 27 is equal to 6 times B plus C. What is B? It's minus 6. So minus 27 is equal to 6 times minus 6 is minus 36 plus C. So minus 27 plus 36 is equal to C. So 36 minus 27, that will be 9, correct? Yeah, that is 9. Unless there's a quicker way, I don't know why, this is 2 marks. You definitely made a mistake with the marks, yeah? Unless there's a faster way to deal with this. Okay, that's what it was. Unless this is supposed to be, I think I mixed up the marks. This is supposed to be here, and this is supposed to be here. Okay. 5.3.2. Right, so now what happens if you worked out 5.3.1 and you are not getting the answer? Does that mean you're going to get 5.3.2 wrong also? No, because they already gave you the answer for 5.3.1. Can you see that? So you're going to substitute here. So my f of x is equal to x cubed, my b is minus 6, and my c is 9. Are you clear with that? So the question is, find the coordinates of the maximum turning points. Okay, so we need to find the first derivative, f prime x. Okay, to differentiate x cubed, that will be 3x squared. Differentiate here, minus 12x. Differentiate 9x, plus 9. You're clear with that now? Alright, so at the maximum turning point, f prime x must equal to 0. So you are replacing f prime x with 0. So 3x squared minus 12x plus 9 equals to 0. We factorize and solve for x. Okay. So I noticed that this 3 is a common factor. Can you see that? So I'll divide by 3. If I divide by 3, I end up with x squared. Minus 12 divided by 3 is minus 4x. 9 divided by 3 will be 3. 0 divided by 3 will be 0. Okay. Easy trinomial to factorize. So minus plus will be minus minus. 3 can only be 3 times 1. X squared can only be x times x. So the factors, x is equal to 3 or x is equal to 1. Now, which one are we not interested in? We are not interested in x is equal to 3. We already know that x is equal to 3 on the graph. Can you see that? We are interested in the other turning points. So we will not waste our time and substitute 3 into the original equation. We know we're going to get 0. That's not what we want. We want the maximum. So therefore, you will substitute 1 into the original equation. This is the one that's required here. Okay, so we're going to go substitute back here. F of 1 into the original equation. So there's a here f of 1 is equal to 1 cubed minus 6 times 1 squared plus 9 times 1. What do we get? 9 minus 6 is 3 plus 1 is 4. So therefore, A is 1